To date, there are more than 13,000 nuclear warheads in the world, with the majority held by the United States and Russia. These warheads possess unimaginable power, capable of destroying civilizations and turning the Earth into an eternal wasteland. But the fundamental question is this: how is an atomic bomb made, and why do only a handful of countries possess this deadly weapon? And still, according to reports from foreign networks, Iran was only 2 months away from building a nuclear bomb. When it is said that Iran was only 2 months away from building a nuclear bomb, it means that Iran had almost reached the final stage in producing fissile material, that is, uranium enriched to over 90%. In this program, we will explain all the stages of building an atomic bomb, from uranium extraction to the final explosion, step by step. So stay with us until the end of the program, and don't forget to like the video and subscribe to the channel to support us. You can also watch our previous programs for reports on the 9 nuclear-armed countries in the world. Uranium, a dangerous element deep within the Earth. Uranium is a natural element but extremely rare and powerful. This metal is found deep underground and in certain specific regions. It can be found in places like Kazakhstan, Canada, Australia, and parts of Africa. Natural uranium consists of 2 types of isotopes: 238, which is inert, and 235, which has nuclear fission properties. Only about 0.7% of natural uranium is made up of isotope 235. This small amount forms the core of nuclear power. Separating this rare isotope is vital, sensitive, and very difficult. For this reason, so far only 9 countries in the world possess nuclear bombs. How is uranium extracted? The process of making an atomic bomb begins deep within the Earth, and uranium is extracted in 2 ways. First, in open-pit mines, giant machines scrape away thick layers of earth to obtain uranium ore. Continuation in underground mines. Tunnels are drilled and reinforced in such a way as to prevent collapse. Miners often work in highly radioactive environments. To reduce risk, remotely controlled machinery is used. But even after extracting raw uranium ore, it requires a complex process to be converted into a usable material for nuclear technology. The first stage is milling and producing yellowcake. Uranium ore is first crushed into small particles and then combined with special chemicals in an industrial setting to produce yellowcake. This substance appears as a yellow powder and seems harmless, but in reality it is a product with a high concentration of uranium, ready to enter a more dangerous stage. Yellowcake still cannot be used to make an atomic bomb, because the active isotopes in it have not yet been separated. To do this, it must be converted into a highly toxic and reactive gas called uranium hexafluoride. Uranium enrichment, separating U-235 from U-238. In the enrichment stage, uranium hexafluoride gas is fed into tall spinning machines called centrifuges. These machines spin at speeds greater than the speed of sound, causing the heavier atoms, that is U-238, to be pushed toward the walls of the device, while the lighter atoms, U-235, remain in the center. This separation process is repeated many times in thousands of interconnected centrifuges. To make an atomic bomb, the concentration of U-235 must reach 90% or higher. This is something that can only be achieved with highly advanced technology and months of effort. This stage is one of the delicate boundaries between science and weaponry. According to reports from reputable international media, Iran had reached a level of enrichment and technical capability at one point that left it only about 2 months away from producing its first atomic bomb. This issue caused serious concern among world powers and increased diplomatic pressure, because such a level of nuclear advancement usually means crossing a red line. In the technical design of the bomb, everything must be calculated precisely. When the enriched uranium is ready, it must be placed in a special mold. The atomic bomb consists of two main parts. One is a projectile made of hollow uranium, and the other is a ring-shaped target. At the moment of explosion, they are brought together. In more advanced models, a special type of explosive called an implosion explosive is used so that pressure is applied from all sides to the center, causing the chain reaction to suddenly begin. Even a millimeter of error in the design can cause an incomplete nuclear fission, so the internal design of the bomb must be extremely precise and accurate. The triggering and timing of the explosion in atomic bombs are usually designed so that they detonate at the right moment. The reason for this is that detonating at a certain altitude spreads the shockwave more widely and reduces the fallout of radioactive rain. The internal systems of the bomb are equipped with pressure sensors and radars that calculate the precise altitude. When the appropriate altitude, for example 1,900 feet, is detected, the detonators use explosives to fire the projectile at the target. The neutrons released collide with atoms and trigger a chain reaction in a fraction of a second. The human and environmental consequences are catastrophic and have no end. At the center of this explosion, nothing alive would survive. In the outer rings, people suffer from severe burns, blindness, bleeding, and cancer. Even kilometers away from the site of the explosion, its effects can impact drinking water and agricultural products. The psychological and social effects are also extremely widespread. The survivors of the bombings of Hiroshima and Nagasaki, known for their resilience and perseverance, still recount the terrifying memories of those days. The reality is that such a human-made explosion can affect humanity for generations. Its effects can impact humanity for generations to come.